Every system has its own control strategy. The analysis and design of this constitutes control engineering. Before building actual systems, the design has to be tested for its performance, stability, reliability, and also economic feasibility. Software tools are handy for carrying out all this before building the actual hardware. Most versatile, powerful, widely used software is MATLAB and Simulink. But for a beginner, procuring the license and working on it is a costly affair. However, there are a number of open source softwares available today which can be effectively and efficiently used for carrying out the analysis and design in par with MATLAB. One such open source software is Python. The library packages of Python are increasing with every version, covering a wide field of engineering. I am Leela here. Welcome back to my channel. I am back with you with a new series of video tutorials on Python for control system. Stay tuned for my upcoming tutorials on Python for control system. Thank you.
Role of software in the analysis and design of control systems. Software tools act as a virtual laboratory instead of building an expensive physical prototype like a real rocket or a factory robot, which may result in crash at the time of testing. This is a risk of crash, which also results in a loss. So, engineers build a mathematical model inside a computer and test for various analysis, and if there is any modifications to be done, that is done at this stage itself before it is taken for building. So the software helps us in three primary phases. The first one is in modeling. Translate the physical components like motors, springs, valves, like this into mathematical equations or visual blocks which relate the input and output. Next is analysis. The software runs the tests to check if the system is stable or if how it is responding, whether it is fast, slow, overshoots are there, oscillations are there, and how it is handling the external disruptions. All this comes under analysis. And in the third phase, the design and tuning. The software helps to calculate the exact parameters of a controller like a PID controller to make the system perform as desired. So main players in the software are in two categories. First one is commercial standards like MATLAB and Simulink. So this is a very heavyweight software which offers incredibly powerful graphical environment called Simulink, where one can literally drag and drop blocks representing physical parts to simulate the complex circuits or complex systems. So next is an open source tools. One such tool is a Python. So this is actually a modern challenger. This makes use of libraries like Python control, NumPy and SciPy. So one can do the exact same advanced mathematical analysis as MATLAB entirely through text-based code for free. So this doesn't need any licensing or investment on this. This is freely available open source which can be made use of. So this is heavily used when interacting control loops with modern artificial intelligence, heavy data analysis and so many things. And in control systems also it's having a powerful control library from which we can design, analyze and do whatever we want. With that said, hello, I'm Leela here. Back to my channel. Welcome to my channel. I'm here with Python for Control System, a new series I'm going to start. And in this season 1, I'll be taking up controls applications for using Python. I'll be using Jupyter Notebook for all my simulations. So guide to installing this Jupyter Notebook from Anaconda Navigator. This is explained in one of my earlier videos. The link is given here. And as far as the Python control system library documentation is concerned, you can go to this website link that is given in this serial number 2 and have an elaborate inspection of the various documentation library systems that are given. So in this season 1, I'm planning to explain the various linear, time invariant, and continuous time systems. I'll be restricting to continuous time, linear time invariant system in this season. So in that, first part is modeling the transfer function. And as a second part, I'll be taking time response analysis for step input, impulse input, and this time response specifications, how we can find using Python control package. Next comes the third part of it is the absolute stability. Given a system, a transfer function, whether the system is stable or not. Fourth part is further analysis with the root locus, an elaborate plot which gives us the location of the closed loop poles as the system gain increases from 0 to infinity. How we can get the root locus in Python and do the analysis as far as stability is concerned, or critical stability, or whatever it is. Next comes the frequency response analysis using Bode plots, then Nyquist plots, and these are also elaborately I'll be covering in this season 1. How to write the code, how to get the various plots, and how to analyze. All this will be covered in season 1 of my series. With this introduction to my new series on Python for control systems, let me dive into the first part of it, modeling the transfer functions.